Hey guys, well in this video we are going to go over the derivative of the first principal rule, and we have a function of y is equal to root x, or we can say f of x is equal to root x. And if we remember, the f prime x, or the first derivative of x, or the derivative of f of x is equal to the limit of, as h approaches 0, of f of x plus h minus f of x all over h. So to do this problem, we are going to say f prime of x will be f prime x is equal to limit of h approaches 0, and instead of writing root x, we can say root of x plus h minus f of x, which is just root x all over h. Now, we have a little bit of a problem here where if we plug in 0 for h, then we get an undefined number. So we have to figure out a way to avoid getting a 0 in the bottom. And one way to do that is, if we notice, we have a conjugate example that we can do in the numerator here. So we have root of x plus h minus root of x. These are probably root of perfect squares, if you can see it that way. So then what we can do is we can multiply the numerator and the denominator by the numerator's conjugate. So that will be x plus h, root of x plus h plus root x. And if we do that, it will look like this. So I'm just going to say limit of h approaches 0 of x plus h minus root x all over h, and then multiplied by top of root x plus h minus root of x, plus root of x, and in the denominator, root of x plus h plus root x, and then this will be equal to, the numerator will be a perfect square, so we'll have x plus h minus x all over h times root of x plus h plus root of x. Now, so this will be, so once again, root f prime x will equal to limit of h as it approaches 0 of x plus h minus x all over h of root x plus h plus root x. Now, the x's cancel out, and then the h cancel out as well. So this will be 1 in the numerator, 1 in the bottom, and this will become f of x prime, root derivative of the function is equal to limit of, as h approaches 0, we have 1 in the numerator, and in the denominator, we just have this part here in the parentheses, which is x plus h plus root x. Now we can plug in the 0. So we have 1 over x plus 0 plus root x. That will equal to 1 over root x plus root x, and that is equal to 1 over 2 root x. So f prime x is equal to 1 over 2 root x. Now, we can go check our answer, and if we have here, I went ahead and graphed our function. So we have the green or red, I'm sorry, I can't tell. So the red, I believe the red one, I think it's green one. The green color, it is root x. This is the function. It's on the positive side because there's no negative in the Cartesian graph scale. So this is just on the right hand side of the coordinates, and then we have the derivative function, which is 1 over 2 root x. And if we look at it, if we say at a function is equal to 1, we have a derivative of 0.5. So when the function root x is equal to 2, we have a slope of 45 degrees. And when x is equal to 2, we have a slope of 0.35. So as you can see, as it close to 0, the line becomes vertical and the slope is higher. And as the number goes, function increases in value, and the x value, the slope decreases and the gradient gets smaller and smaller and smaller. So I hope this makes sense. That is the first principle of the derivatives. I hope this helps you build your calculus skills and algebra skills, and I hope you pass your exams, and I'll see you guys in the next one. Bye.